Hello, students. Very good. Welcome back. We're going to continue today with Lipids Part 6. Lipids Part 6. Okay. Now, one thing that we have not talked about since we've started drawing our lipids is the stereospecific numbering. So I'm going to draw for you one lipid, one glycerol phospholipid, and I'm going to make sure I show you how we name that correctly, completely, using our SN configuration. So here we have, going to have glycerol here. H2. Now, when you draw a lipid in the correct orientation, make sure you put carbon 1 on top. This is going to be in the Fisher projection, and the only carbon that matters is going to be the carbon number 2. And so just make sure for carbon number 2 you put the O, or you put the fatty acid to the left. Okay, and let's see what lipid I'm going to put here. I'm going to put palmitate here, so that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I'm going to put, well, I'm not going to put it. I'm going to put it here. I hope you all didn't write that. I hate that. I hate when I make those mistakes like that. I'm going to put the palmitate on the first one, and I'm going to explain to you why in just a second. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we're putting palmitate on carbon number 1. And on carbon number 2, we're going to put our unsaturated fat on carbon number 2. Whenever you make a phospholipid, usually, well, in most cases, the saturated fat is on carbon 1. The unsaturated is on carbon 2. So let's put palmitoleic on 2. So it's going to be 2. Oops, not go up. I'm going to go down on this one. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And so on carbon 1, we have palmitic. And on carbon 2, we have palmitoleic. Where can you find a lot of palmitoleic or palmitic fatty acids? In what plant? Palm trees. Very good. Exactly. Makes sense. And for carbon 3, it doesn't matter which side the phosphate is on, but the phosphate has to be on 3, of course. And so this is going to be O, P, O, O, O. And let's just make an entire fatty acid. Let's go ahead and give this one a head group. The only reason I'm doing this is to show you how to completely name a phospholipid. And we'll just use any head group that we've learned. Let's use choline. CH2, CH2, N, and then 3 CH3s. Okay, and we need to put our H here. Now I'm going to give you the entire pseudo-systematic name because we're going to use the common names of the fatty acids here. And so, since we're using stereospecific numbering, now, okay, I'm going to ask you all a question. Of these 3 carbons, the first carbon, I'm going to use my arrow here. I want to ask you all, the first carbon has a C bonded to an OC. The second carbon has a C bonded to an OC. The third carbon has a C bonded to an OP. Of those 3 carbons, which one is going to have the highest priority? The third carbon. So that should be the 1 carbon. If we were using our conventional numbering scheme, that would be carbon number 1. But we're not using conventional numbering scheme when we deal with phospholipids, because glycerol is achiral, and if we number it that way, it becomes what's the word? Ambiguous. And so we use another numbering scheme, and we call that the SN, the stereospecific. So I'm going to give you the complete name of this. This is called SN, using stereospecific numbering. This is SN 1-palmitoyl. 1-palmitoyl. Now the whole name should just go straight across, but I'm going to go down with it because it'll be easier for you to see. So this is SN 1-palmitoyl 2-palmitoleoyl 3 phosphatidylcholine. And that's the complete name of this phospholipid. All of the phospholipids that we drew before, we didn't put SN in front of it, but all of them are SN. All of them are SN. So if you Googled it, it's going to always have SN in front of your glycerol phosphates or your glycerol phospholipids. Everyone okay with this? Okay. Now, one other thing I want you to know about the phospholipids, and I've alluded to it already. Your very first, your fatty acid on carbon number 1, or I'll just put your 1 fatty acid. It's going to, most of the time, it's going to be saturated. It's going to be saturated. That first fatty acid, the fatty acid on carbon number 1 is going to be saturated. And the fatty acid on carbon number 2 is going to be unsaturated. And this is in biological organisms. So in us, we would find 1-palmitoyl 2-palmitoleoyl 3-phosphatidylcholine. But we would not find 1-palmitoleoyl 2-palmitoyl 3-phosphatidylcholine, because the second carbon's fatty acid is the saturated one. Make sense? I mean, is unsaturated. Thank you. The second one is unsaturated. The second one is unsaturated. The first is saturated. Everyone okay with this? Excellent. Excellent. Okay. Now, let's see. If you all can remember, what is it? The beta-1 adrenergic receptor. The beta-1 adrenergic receptor went with GQ. It was beta-1, GQ, and then there was an enzyme that clipped the phospholipid. Anybody remember the name of that enzyme? 1Q. Remember? C, exactly. Remember 1, 2, 3, 1QC. Phospholipase C. That was and so phospholipases cleave phospholipids. Now what I'm going to do here, I'm going to just draw a generic phospholipid, and I'm going to show you where they're cleaved. Okay, and so let's just draw a generic phospholipid here. Okay, I'm going to put C, 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 and I don't care which one this is here. O, P, O. Oh, I'll just put an R here because it doesn't matter. Now, carbon number 2 has to go to the left as you're going to put it in Fisher projection. So I'm just going to put O, C. Can I just do this here? Is that okay with you all? And I'll just put a bend there and a double bond because I don't care what the fatty acid is. And on number 1, we'll put another bond here. What's the name of that bond that holds these phospholipids? I mean, holds these fatty acids onto these phospholipids? Ester bonds. Okay, and so this is CH2, and we have to put here our H, and this is H2. Okay. Now what I'm going to do, I'm going to show you all the places that it can be cleaved. Okay. And then I'm going to give you the name of these bonds. Okay. Let's find all the places where it can be cleaved. Let's use this. So we can cleave here. We can cleave here. In all of the places yeah, I think I made a mistake here. Okay, and here and here. Okay, those are the places. I think all of the places that are cleaved are always next to the double bonds. Okay, so these are phospholipases. Phospholipases. Phospholipases cleave phospholipids. And so we're going to name these phospholipases. So we're going to put here phospholipases. Okay. So now let's name these phospholipases. There's a phospholipase that cleaves here. And let's give things a different color here. Okay, a phospholipase that cleaves here. It's called phospholipase A1. Called phospholipase A1 because it cleaves at phospholipid at fatty acid number 1 or at carbon number 1. So that's phospholipase A1. I'm going to show you these reactions in just a second. Make sense, kind of? Okay. Let's see how much sense it makes. There's a phospholipase that cleaves right here. Can anyone tell me, especially this group here, what's the name of the phospholipase that cleaves at carbon number 2 or cleaves fatty acid number 2? Phospholipase A2. Make sense? Excellent. So this is phospholipase A2. Okay. Now we don't have any more fatty acids, so we can't use 1 and 2 anymore. So we can have there's a phospholipase that cleaves here. Anybody want to venture to guess what that phospholipase is? Say that again. Not quite B. C, phospholipase C. And it's not C1 or C2. It's just phospholipase C cleaves here. There is no B. So there's just A1, A2, C. And there's one more left. Now these are popular ones. A1, A2, and A3 and C are popular. But this last one is not that popular. Anybody have any idea what we'll call this one? D, exactly. And so this is phospholipase D. Okay. And so those are the 4 phospholipases that cleave this phospholipid into different pieces. Now those pieces are important. We can use those pieces for signal transduction. For example, if you use phospholipase C, you can make diacylglycerol and you can make IP3, and those two do things. And we'll look at that one. Some of these phospholipases, the first one that we're going to look at, in snake venom. When a snake bites you, it has phospholipase A in it, and A1 and A2, and basically it just destroys the cell membrane, your red blood cell membranes, and that's how snake venom kills you. Because when your cell membranes are destroyed, then all of the contents of your cells just fall out of the membrane, and you could die. And so that's how snake venoms work. And so let's look at each of these phospholipases. The first one is going to be phospholipase A1. We're going to look at that. We're going to look at that cleavage and see what the products are. Everyone okay with that? Excellent. Okay. And so we're going to make ourselves a phospholipid here again. We're going to have I'm just going to put OPO3 now because I don't really care. That's phosphate. And here I'm going to put any phospholipid, but it's going to be saturated. So I'm going to put a bend there. And on the first one, is this one going to be saturated? Yes, it is, but we don't care which one it is. It's just a saturated fatty acid. And so here we have a generic phospholipid. Okay? Now what we're going to do here, we're going to cleave right here. What enzyme is going to do this cleavage? Phospholipase A1. So we're going to put here PLA1. And so when we do that, we're going to create two things. We're going to end up with just our fatty acid. We're going to have just our fatty acid. Is that fatty acid going to be saturated or unsaturated? It's going to be saturated because we cleaved with A1. And then we're going to have CH2OH, CHOC, CH2OPO3, R. Now we're going to have a phospholipid without a fatty acid, without one of its fatty acid. And any phospholipid that does not have a fatty acid, that's called a, we've lysed one of the fatty acid. What does the word lyse mean? To cut or to cleave. And so we call this phospholipid now, we call it a lysophospholipid. And so phospholipase A1 leaves you with a fatty acid and, well, a saturated fatty acid and a lysophospholipid. It's a fatty acid, it's a phospholipid without one of its fatty acid, with one of the fatty acids removed. That's a lysophospholipid. Now, they're found in our body normally for signaling. Like if we want to have some sort of signaling event to take place, we have phospholipases in our body. But there's a certain animal that has lots of those, and they use them to kill you. What animal is that? Snake, exactly. So snake venom has lots of phospholipase A1 in it. And that's bad for you. But the phospholipase A1s that we have in our body, those are good for us. Make sense? Exactly. Okay. Everyone okay with this one? So now we've done phospholipase A1. We've shown you the reaction. I'm going to put an arrow here to show the products. Which one should we do next? PLA2, phospholipase A2. Okay. So let's do it. I'm going to do something. Question. Okay, the question is, if we already have phospholipase, I'm going to go back to this. If we already have phospholipase A1 in our body, then why is snake venom toxic to us? Does anybody have any idea what the answer might be before I give it? Exactly. Say that again. Yes, it's too much. Snake venom has lots and lots of A1, so it destroys all of the membranes. The parts that the ones that's in our body, it just cleaves maybe one or two of them, and those one or two, either the fatty acid or the lysophospholipid, go into a signal transduction cascade. But when a snake venom, it cleaves everybody and just destroys the whole cell membrane. Make sense, kind of? Question. Okay, now, the reaction is a hydrolysis reaction. And in hydrolysis reaction, you add water in any type of biochemical cleavage reaction. When you add water, you split the bond. And so what I didn't put here as another one of the reactants is water, H2O. And so when that water comes in, well, I'm going to put it this way, HOH. And you can see here, the OH is going to go with the phospholipid, and the H is going to go with the glycerol, and you're going to end up with these products. Make sense? Yeah, it is, because, oh, excellent question. He said he thought that the phospholipid was hydrophobic. Exactly. So when you have your phospholipids like this, oh, great questions. I'm going to put one phospholipid, one part of the membrane right here, and I'm going to put the other part of the membrane right here. Okay? And so that's going to be the whole membrane here. Out here, we're going to have our water, and we're going to have water here. And so when you have your phospholipid here, your phospholipase is going to be right here. And it's going to go and it's going to cleave right here. And that's what's going to release. It's going to be able to use that to release those two. So the water can still have access to those head groups. Excellent question. Absolutely excellent question. Make sense, everyone? Okay. Let's go back here. So we've done phospholipase A1. Let's look at phospholipase A2. Okay, I've run out of blank pages, so let's make a few more. Okay, phospholipase A2. And so I'm going to just redraw my phospholipid here. Okay, C. Okay, that's going to be O, 2, 3, 4, 5, 6, 7, 8. No. I'm going to do it a little different this time. No, I'm not, because I want you to see what I'm doing. Okay, there's one. Why am I putting a bend always? Why do I always put a bend in the second one? Because it's always unsaturated. Unsaturated, exactly. CH2, CH, and then O, PO3. And this oh man, I wanted to show you all the special case. I wanted to put the actual phospholipid here. Has anybody drawn it? Wow. I need to, because it's a special case. Well, phospholipase A2 can cleave any of them, but this one is a very important one, and I wanted you to see that one, because that one's going to come up when you do signal transduction, especially if you go into medicine. This fatty acid is really important. It's really important. So I'm going to put arachidonic acid here. Okay, and so that's going to be 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And so this second one is arachidonic acid. And then here we're going to have H2. And so there's our phospholipid. The first fatty acid doesn't matter. The second one, the fatty acid on the second carbon, that's arachidonic acid. Arachidonic acid is important in your sensation of pain. Arachidonic acid allows you to sense pain. I'm not going to go into that that biochemical mechanism, but you have to have the arachidonic acid for that. Oh yes, arachidonic acid. ARACHIDONIC. Arachidonic acid. And it comes from the Greek word arachis. And arachis means, I know what this, let's see if I can draw this. Let's see, anybody know what that looks like? What is that? A peanut, exactly. Arachis means peanut, and so it was probably first found in peanuts. It's a pain reception, your reception of pain. And so what happens, arachidonic acid is converted into these prostaglandins, and then this enzyme called cyclooxygenase comes in, and it creates something that allows you to sense pain. But when you take something like aspirin, aspirin blocks the cyclooxygenase, and so you don't get the prostaglandin form, and you don't feel any pain. So that's the beauty of aspirin. But we won't talk about that now. I don't want to get you confused. Question? Now, talking about when they, Oh, the phospholipases, like in spider venom, I think spider venom actually has not phospholipases. They have neurotoxins in them. Spider venom has neurotoxins, and that's how they exert their effect. Okay, and so here we have arachidonic acid in this phospholipid, and now this is the bond that's going to be broken here. And so what's going to be the phospholipase involved? Phospholipase A2. Now let's look at our products. That peanut is going to be kind of in my way, but I'll just draw it here. Okay, we're going to have arachidonic acid here. So that's 2, 3. Yes, it's going to be hot water, exactly, because they're all hydrolysis reactions. In biochemistry or whenever you cleave a bond, you almost always use water. Whenever you cleave, like a peptide bond, those proteases use water. When you a phosphodiester bond between nucleotides, those nucleases are going to use water. That's hydrolysis. And when you have carbohydrates, when you have glycosidases, they're going to use water. Those are hydrolyses as well. Okay, let's redraw arachidonic acid. That's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay. So here we're going to, when we do this hydrolysis, we're going to end up with arachidonic acid. Arachidonic acid plus, we're going to have our, well, I'm going to put here, water's a reactant. Plus, we're going to have our the rest of our phospholipid, P03. And it doesn't matter what that is. So we'll keep this one. We'll keep number 1, but we'll lose number 2. Okay, and so on the left we have arachidonic acid, and on the right we have our phospholipid without one of its fatty acids. What do we call a phospholipid that's lost one of its fatty acids? A lysophospholipid. And this would be a 2-lysophospholipid, but it's just a lysophospholipid. There's a lysophospholipid. Now, arachidonic acid can go to make lots of eicosanoids. It can make eicosanoids. Things like your prostaglandins. It can make thromboxanes, which are involved in clotting. And it can make leukotrienes, which are involved in like leukopoiesis, the movement of your leukocytes. And so arachidonic acid is very important. And these things are called eicosanoids. Eicosanoids. E-I-C-O-S-A-N-O-I-D-S. Let's make that clear. E-I-C-O-S-A-N-O-I-D-S. Your eicosanoids. Question? Yeah, leukotrienes. Exactly. Leukotrienes are involved in the movement, the migration of your white blood cells. You can think of leukotrains, like a train moves and white blood cells move. Leukotrienes. And so this is our second phospholipase. I'm only going to show you the mechanism or the actual reaction of 3 of them. The 3 important ones. A1, A2, and C. I'm not going to show you D. Now, this one is also found in an animal. Phospholipase A2. What animal is this one found in? What's that? Exactly. It's found in snakes as well. Let's see if I can draw a snake here. Wow, that's pretty good. And so it's found in snakes as well. So we have phospholipase A1 and A2. Both are found in snakes. Both are found in snakes. Question? Again, what they do, they just cleave all of the fatty acids off of all of the phospholipids in the membrane, and then once you destroy the cell membrane, then your cytoplasm can leak out. Yeah, same thing, exactly. And it just destroys it. Her question was, what does phospholipase A2 do to the membrane? It's the same thing as A1. It just destroys the membrane, whole cell destruction of the membrane. No, lysophospholipid is just the product. After you cleave, after A1 and A2 cleave, that's the product. And the lysophospholipid can't hold the membrane together. You need complete phospholipids to hold the membrane. In the venom just has the enzyme. Just the enzyme. And then after the cleavage takes place, then you have all of the products, so just in the person's body, the destroyed products. Okay? Let's do the last one. What's the last one going to be? Phospholipase C. And I'm going to actually show you the specific head group on this one. It can be anything, but this one is important in signal transduction, so that's why I'm showing you this one. Okay, we're going to put C, 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 O, C, and we don't care what that is. O, C. We don't care what this fatty acid is, but we'll make it unsaturated. H2, H, H2. But now we do care now what this product is going to be. Okay? I mean what the head group is going to be. So I'm going to draw a head group, and let's see if you all can figure out what it is. I'm going to make it blue here. Okay. I'm going to go down, down, O, P, O, down, 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 and then up, up. I'm going to now, if you all would, in 3 of these places, 1, 2, 3, here, don't put this H here because you're going to erase it in just a second. And this is going to be down. And don't put that one. 1, 2, 1, 2, 3, 4, 5. Okay? Those 2 we're going to erase. But can anyone tell me the name of that head group? Or what's the name of the phospholipid? We've done it. Remember? 3 are down, 3 are up except for 1. No one can remember? Wow, that's kind of disappointing. But that's okay. That's how life is sometimes. Sometimes you teach in vain. Okay, this is going to be phosphatidyl inositol. Remember that? That's phosphatidyl inositol. But I'm going to change phosphatidyl inositol just a little. Instead of having those H's there in those 2 places, I'm going to erase those, and I'm going to put phosphate groups. So I'm going to put PO3. PO3. I'm going to put phosphate groups. And so now, this is no longer phosphatidyl inositol. This is phosphatidyl inositol 4, 5 bisphosphate. Phosphatidyl inositol 4, 5 bisphosphate. Why is it called bisphosphate and not biphosphate? Right. Only if they were connected to one another, then it would be biphosphate. Because the two phosphates are not connected, it's bisphosphate. This is the last one, you all. Stay with me. Okay? Now, what phospholipase are we going to use here? Phospholipase C. And I'm almost sure it's right here where it cleaves. I have it in another place on my notes, but I think my notes are wrong. I think it's phospholipase C. But if it's not, I'll fix it in the editing of the video. Okay? So there's phospholipase C. And now let's look at our products. It's going to be hydrolysis. So what else do we need if we're going to have a hydrolysis? So we're going to have water too. Okay? So if you all allow me, I'm going to select all of this and make it smaller. Because I'm going to need room down here. So I'm going to do this. Okay. There we go. So I'm going to select this, make it smaller. I'm going to group this. And I'm going to put it right here. Okay? That's not good. Okay. I don't like to rush at the end because I would be rushing. Would you all put your notes? Can I continue this on next time? Okay, great. Let's put your notes away and let's see how you all do. Okay, remember I need... Okay. Let's get rid of this. Turn the screen off. Okay. Okay. What is the name of the phospholipase which will remove an unsaturated fatty acid? I need this group here to be very vocal and animated. Which will remove an unsaturated fatty acid. Exactly, phospholipase A2. What's the name of a phospholipase that would remove the phosphate group? Phospholipase C. And what's the name of the phospholipase that would remove a saturated fatty acid? A1. A1, very good. Which phospholipase? Oh, question. What animal has lots of phospholipases? Snakes. Which phospholipases are found in snake venom?
A1 and A2.
A1 and A2. If A1, what two products are formed by snake venom on a phospholipid? What two products are formed? A lysophospholipid and a fatty acid. You know, water is not a product because water is used as a reactant. Okay? And let's see, last question. Yes, this is the last question. In the signal transduction cascade, you have the beta-1 adrenergic receptor activates GQ, the G protein GQ, and that activates phospholipase C. Phospholipase C releases IP3. What does IP3 do in the signal transduction cascade? Say that again. It releases calcium from the ER. Very good. You all have a great day. Don't unplug the camera. Y'all for a look that time. I'll try to remember. If it's not changed by Thursday, keep that up out here.